Calculating the enthalpy change of a reaction using provided bond energy is one of the most common questions in paper 2, EDEXCEL IGCSE Chemistry. This is a past paper question, and in this question, there is a reaction between ethene with the addition of bromine to give you the dibromo compound here. And they provided you with a table for all the different bond energies and want you to show that the molar enthalpy change for this reaction is about minus 100 kilojoule per mole. So we know that delta H equals the energy needed to break all the bonds for the reactants minus the energy needed to form all the bonds in the product. So energy of broken bonds in reactants minus energy of bond formed in products. You have two ways to calculate the bond energies here or the energy here. Either focus only on the bonds that were broken and the bonds that were formed, or use the bond energies for all of the reactants and the products. Here, only the carbon-carbon bond was broken, and the bromide bond or the Br-Br bond was broken for the reactants, and the only two bonds that were formed are the C-Br bonds. As you can see, the carbon-hydrogen bonds, there are 4 carbon-hydrogen bonds, and they stay exactly the same, so they were not formed. And then we have the carbon-carbon single bond also was formed because we broke the double bond and made a single bond. So we can focus on only these bonds and ignore the carbon-hydrogen bonds in our calculation, because for both reactants and product, there are 4 carbon-hydrogen bonds. So they will basically cancel each other out, and we can consider them as they haven't been broken or made. So now we can calculate the energy of the bonds broken, total energy of bonds broken. That will give you one of the carbon-carbon double bond, so 612 plus the 612 plus the bromide or the RBR bond, which is 193. And that will give you a total of 805 kilojoule per mole. And then we need to calculate the energy of bonds formed in the product, and that will give you 2 of the carbon bromide bonds, so 2 times carbon bromide 276 plus the carbon-carbon single bond, which is 348, and that will give you a total of 900 kilojoule per mole. Now the delta H will be the total energy of the bond broken, which is 805, minus the total energy of the bond formed, which is the 900, and that will give you minus 95 kilojoule per mole. So delta H here is minus 95, and they wanted you to show it's about minus 100 kilojoule per mole.